Up next we have Binqi from PolarSeven. He's going to talk a bit. Has anybody heard of the Internet of Things? Yeah. Anyone?
Cool.
Yeah. Excellent. So I think it might be slightly on topic. So Binqi will just give us a bit of a talk about it now. So take it away, Binqi. Thank you.
Thank you, Daryl. Alright, before we dive into IoT, a little bit about myself, about PolarSeven. So, who is actually the little Asian guy standing in front of you, interrupting your bearing session? My name is Binqi. Some people call me Binqi. Some people call me Binqi. Doesn't matter, I know you're calling me. So what I've been doing, I've been doing a PhD and I'm about to finish a degree in distributed systems. I've been working in the IT industry for more than 12 years, started from embedded software development, firmware, a little bit about system services, and I did a little bit project management and precepts. So my background actually was about systems, x86 servers, data center, and cloud. And I've published about more than 10 books, academic research papers, and I've got a few US patents submitted. Just recently got one Australian one submitted. And in the past 18 months, I've been working on an IoT project. That's why I'm going to give you a talk about it. Hopefully, that can bring you some useful information, some good takeaways. And recently, I joined PolarSeven as an AWS and DevOps consulting engineer. Any questions so far?
Do you use Twitter?
Yeah, sure. We can exchange that details in the next video session. Well, about IoT. IoT is Internet of Things, and someone's talking about IoE, Internet of Everything. A few years ago, this buzzword emerged as 3 I's: intelligent, instrumented, and interconnected. Unfortunately, the instrumented, this I goes away. I never see it again. So basically, I think Internet of Things primarily is talking about intelligent and interconnected. So many things are actually not new. So if you talk about a sensor, this dialogue can be 20 years old. 20 years ago, you got sensor, right? And why didn't we call it Internet of Things? Because they are not connected. They actually sit at different geographic locations and they don't talk to each other. And intelligent, initially it needs to be digitalized. So think about this light bulb. These look like beautiful vintage light bulbs. But you know what? Today you can make the same look and feel by LED technology. LED is digitalized, so that means you can control the dimming levels in a finer grain, passing software signals like RESTful API. It just pass the value and it will show you the right dimming level. So that's called intelligent. So really, the evolving technologies, including the mobile phones. Everyone's using mobile phones, and it's getting cheaper, it's getting more affordable. And you've got a very good ecosystem like Android and iOS. You can easily publish your app. So everything actually brings the IoT to a new stage. We've been talking this for years, but not until recently it got more traction. Look at these figures. These figures are from a very famous IT research institute. By 2020, how many people will be connected? About 4 billion. A little bit more than 50% of the global population. But how many embedded intelligent devices will be connected? More than 25 billion. That's 6 times more than people got connected. So it's machine to machine. It's no longer like people to people or people to machine. It's machine to machine. And essentially, more importantly, you got 50 trillion gigabytes of data. Every intelligent, interconnected device actually generates data at all times, if you wish. Why not? Sometimes you have to confine that device from generating data just because of saving energy. So I'm going to talk about a little bit about the constraint at a later time. Essentially, why we're talking about IoT here? This is the AWS Meetup, right? It's not an IoT Meetup. It's not a Raspberry Pi Meetup. It's an IoT Meetup. So why does cloud matter in IoT? If you look at this, if you look at the left-hand side diagram, it's a very typical IoT architecture diagram. So right from, actually I should present in another way upside down, but if you go from top to bottom, the devices that we are familiar with, either in a home automation context or a personal wearable device, PWD is a personal wearable device, sorry for the jargon, should have full names. But anyway, it's like a light bulb, Apple Watch, smart lock, curtain or whatever, interconnected, intelligent. Then you go to the IoT networks. This space, to be honest, this space is a little bit chaotic. So there are a lot of competing protocols in this space. Zigbee, Z-Wave, Bluetooth, low energy BLE, Wi-Fi, RF, low frequency, radio frequency, RF technologies, just to name a few. So people easily got confused. So if you go to an IT shop, say, hey, I need to get my home equipped with a smarter home automation technologies, what should I choose? They actually, different protocols are operating at different radio frequencies, and they have different protocols. They don't talk to each other. Even under the same telecom or data access layer, IEEE 802, 1504, that's Zigbee. Even the same telecommunication protocol, on top of that, you can build different applications. And Google built, I think the Smart Things by Samsung, they are building something called Thread on top of the Zigbee. So you can see a lot of variations in this space, and it's very chaotic. But essentially, you need a gateway to be interconnected to the internet. Otherwise, it's connected within your home. You can't do much. A gateway actually connects the IoT network, all the devices into internet. It's a bit different from the other gateways we'll talk about, but essentially you can think of it's like a multi-purpose network device. On one hand, it has a very good wireless sensor network technologies integrated. On the other hand, there's a Ethernet cable or Wi-Fi connection into the internet. And what's behind that? That's the cloud. Why do we need a cloud? As I mentioned in the previous chapter, more data are created. And if you are from traditionally, let me ask one question. So how many people like here holding an electrical engineering degree rather than computer science? All right, about 15-20%. Yeah. So if you're coming from this space, if you work with the embedded systems, you're not really familiar with cloud traditionally. And I think your focus is on how to design a very good circuit board, how to integrate the right chip into the solution. But you don't know how to deal with the massive amount of data. Some people, they actually don't know, but they actually just try to store the data until you understand more how to deal with that. So essentially, you need to push the edge into the cloud. A few things. The cloud actually provides persistent connection and data storage. Like I said, if you can't really analyze and utilize the data, you can push that into the cloud, properly stored for future use. Why do you need a persistent connection? I'll give you an example. A typical home automation service will actually offer you remote access to your home when you're away, right? think about the light bulb, think about your switch, think about your power receptacle. These things, you need to control them, you need to send home a command, and it needs to be responding in a timely manner. So the gateway actually keeps the persistent connection with the cloud and the internet. And cloud is actually, in this case, acting as a commander. Send all commands, get all the information, and you are actually the user. When you're away from home, you are interacting with the cloud. You're not interacting with your wireless sensor network. And it's scalable. Like I said, people like me, I'm also holding a EE degree. Traditionally, when we designed the embedded system, we didn't know what to do with the scaling computing resources. So cloud infrastructure, cloud technology enables you to focus more on the design of the IoT itself and leave the computing resource, storage resource, network resource to the cloud expert. Amazon just announced a service in Sydney region, AWS IoT, last month. And want to look into the competition. This space has been getting big. In my previous project, we've been using a platform called Iot. Because the service was not, AWS service was not available in Sydney region. As you may know, because we're dealing with the user-sensitive data, right? It's about the confidentiality and the privacy concerns and regulatory. You have to put the data within Australia. Because we were doing a prototype, probably that's fine. Iot, the hosting service in the US, some piece in China. But when you try to move things into production, that's a serious concern. You have to choose a proper service provider which hosts all the data services inside Australia. If you look at the competition space, these are like traditional system providers: Samsung, Cisco, Huawei, IBM. They are working on the protocol or communication layer. They are trying to integrate different protocol into their platform. So let's go back to this page. So they try to Thread or smart things. They actually support Zigbee, support Z-Wave, they support Wi-Fi. They actually certify different products and they provide an integrated gateway. That means even if there are a lot of different network protocols working at your home, as a user, these are transparent. But they are doing things at a lower level, right? Level 2 or level 3. And other folks like iLab, Buddy, Alibaba Cloud, they actually offer some interface, programmable interface, serving as software as a service. But these mostly you are talking to proprietary integration or interface. What AWS doing, on the other hand, at the first place, they have a very mature ecosystem that provides multiple services. And secondly, specifically to IoT provider, all the implementations are standardized. That's an announcement on AWS website. The service was available on July 7th. That's why I think it's about the right time to make such a talk. And how is AWS IoT service different to the other, competing solutions? And with the existing AWS services? First of all, it's about new pricing model. Look, this computing resource is no longer measured by EC2 instance or by the storage capacity. It's measured by message. Because a typical IoT application does not have a huge amount of data bandwidth requirement unless you're doing video surveillance. If you just try to turn on a light bulb or remotely control a smart lock, you just send a very short message. But given the scale of the solution, like each home, you got 20 devices, and then if your solution is targeting 20% of Australian homes, so think about the number of messages you are actually processing. The definition of the message right now it's like a very short. It's about, I think it's about 90 bytes. They define every 90 bytes data packet as a one message. So every month you got 250,000 messages free. That's a free tier, and you pay for just $5 per million. And by subscribe to IoT service, you got free delivered to other service. Like if you want to push the message into S3 for permanent storage, if you want to run some processing script in the Lambda, or you want to do more streaming services with Kinesis, these are all the free services that you can use. So you just pay for the message. They measure your usage by message. And they integrate with the de facto standards. I'm saying de facto because they're not like IEEE or something, but in the space of IoT, MQTT is a de facto standard for real-time messaging. And HTTP, surely that's a www standard. This is a bit technical. I won't spend much time, but just want to give you a sense that pretty much all the requests or response are based on HTTP or MQTT service. So when you actually connect your home to the internet or connect to your watch or whatever, you actually are publishing a message by MQTT protocol to the cloud, and you also can have your mobile app, for example, as a subscriber. When there's a message published to the cloud, and then you can receive the message as a subscriber. You can also integrate like third-party services like IFTTT. This gentleman asked me about Twitter. You actually can tweet to turn off your light, and who's gonna win the echo? If you've been to AWS Summit this year, they demonstrate the what's Echo's name? I think Alexa. Alexa. From last year, we play with Alexa. Turn on all the lights. Turn on the heat. It's too chilly. Things like that. You can easily do that. So Alexa can be a subscriber, or sometimes can be a publisher. It's just like integrate the voice recognition and the cloud service into your solution. And it's not the end of the game. So I think this talk is a little bit different because for the IoT stuff, you can not only use it or explore it as a business, you can also treat it as a hobby. Myself, I ordered a few Raspberry Pis, and as well as the accessories to build my own video surveillance. Very cheap, $50. And you can make whatever chip you want. It gives you a Debian programming platform. And now AWS offers this service. You can easily register into that. So as a side project or as a hobby, whatever, now you got more flexibility and more choice. And you can potentially utilize AWS big data services if you want, have interest to look into all those logs or messages that you get from your device. But if you're going to develop a serious offering, a commercialized product, especially the production environment, you need to take into account a few things. So first of all, you need to focus on the design, not the connection. Because in my previous project, I focused like 18 months. The hardest part is not software. It's not about internet connection. It's not about Zigbee connection. The hardest part is industrial design. How to design a beautiful power switch that makes makes it appealing for people to replace the current ones or into a retrofit environment. That's very important. And focus on the reliability of electronic design. Right? You don't want to get it burned. You don't want to have it somehow violating the telecommunication protocols and things like that. And at the same time, you also want to make sure there's a good connectivity. If sometimes the device can be based on power, based on battery, and then you'll be very careful when you design the software. What will be the interval of polling, right? If you keep polling the device once every 3 seconds, this battery will last only for 2 weeks. Some other product they actually commit 5 years lifetime, but you won't get an update like every 20 minutes, I would say. So the response time, energy consumption, reliability, these are all within the triangle constraint. So you need to think about a lot of things, a lot of trade-offs. Data security and privacy. We've been doing a lot of testing, prototype, but we didn't go to production because we did not have the experience of security and protecting confidentiality. Because we understand that if you do that without much confidence, you may end up losing money because it's a very serious concern as a user. So you can easily sell things, but what if they come back and sue you, right? Analytics and data sets, this actually, we view it as a gold mine. You actually can generate a lot of user values in terms of data, but many people don't know how to do that. Many business models are not there, but essentially you need to store the data set. Extensibility and scalability are good things that AWS pretty much will cover for you, and standardization. So why this is important? Because think about it, if you are developing your IoT solution, you definitely won't dominate the home, right? Because you don't do AV stuff, other people do. You don't do the gaming console. You don't do air conditioning. So you can only do a very small piece. You may end up selling multiple brands into the user, and into user's home. But if these solutions and products are not actually compatible to each other, essentially nobody will be buying your solution. So standardization, compatibility is very important. At least you need to seamlessly plug into, let's say, Apple Home or Apple Health, right? So that's the end of it. Because smaller business will not be able to dominate the launch anyway. So we have to leverage big players like Google. Well, more information about AWS IoT. We've got some very good articles regarding IoT release on our blog. So check PolarSeven blogs. And again, thank you for listening to me. I appreciate that you all come together in this wild weather, and I hope I can come back in a few months after I play with the IoT services in the Sydney region and can share more stories. If you have an interest developing a side project or hobby, I'm more than happy to work with you. Thank you very much. I'm actually too nervous.
Good work, Vic. That was awesome. Thank you very much. Any questions from anyone here? Questions, anyone? No? I thought at least somebody would have one question. I got one. So how come what are some of the challenges of building an IoT solution?
Yeah, that's a good question. I think during my talk I already mentioned, initially you were thinking about a architecture or solution. You need to, if we go back to that chart, you need to figure out what device are you targeting, what's the use case, right? And if you're thinking about integration, should I support Apple? Should I support Google? Should I support Samsung SmartThings? And what kind of telecommunication protocol should I choose? Some lower frequency, they really have very good penetration, across this wall. but they have very low data rate. So depending on your application, you need to do a trade-off. And also, you need to figure out what form factor of your gateway should be. Should it be a USB key that plug into your router, or should it be like a fire alarm, because every home is equipped with a fire alarm? So some users they don't like introduce an ugly box. You already have a router, you already have a Foxtel box. You don't want to introduce another ugly one. So things like that. After you deal with all the things, you figure out the cloud, big data strategy, hosting services. And then if you look into the details, you draw the PCB board, you choose the chips, and you test the RF performance, the connectivity, and you test with the cloud services. So these all coming together for PolarSeven.
A lot of different technologies.
Yeah, and then
stacks,
exactly. So
a bit of fudge. You don't know if you're uncertainty and doubt. There's a lot of that thrown in as well. And will this work? Okay.
Yeah, so it's a magic, if you can put something together and get it working in 18 months. But more challenging stuff is to get it into product.
Question, Shane? Device registration as an issue, yeah. Device upgrades, yeah.
Yep. Device registration, device upgrade. You said you had 3 questions. Yeah. Okay. Cool. Yeah, that's a good point, because device registration, you want to uniquely identify one device. So for a few reasons. So I think Australian consumer law actually protects we as a consumer. You can actually return or asking for repair 5 years. So you need to make sure. As a service provider, as a product provider, you need to make sure every single device, no matter how small it is, trackable, it's uniquely identified. And yeah, I will take your question later. And secondly, these devices are tiny, small with the firmwares. The connections are often not broadband, they're narrowband. Zigbee, for example, the data rate is 115 kbps. So it's a bit painful if you want to do a firmware update. And essentially, firmware update is a very tricky thing. So if you flash the firmware instead, you have to you pay for $100, hire an electrician to take it off. So the device itself is $20. Think about that. So yeah, these challenges will definitely result in more diligent design work for software engineers.
Awesome. Anybody here doing IoT projects?
I think that's
before we get to the question, who here is doing an IoT project? So we have a couple. Are you using AWS IoT for that? No, so you're just
it's one month old in Sydney, but it's like only 1 year old in US.
Yeah. Sorry, question over here.
So your question is about how to track the device, right?
That make sure a device is trackable, no matter how small it is. Is that what you mean?
Right. Exactly. Yeah. Okay, I got your point. Yeah. Yeah. So I think the question is, I guess a dilemma, because as a manufacturer you want to track every device that you ship, but the user may not want to track their behavior, right? So it's kind of a device thing and user behavior. So I think typically nowadays all the providers, they will ask you to sign an agreement before you use anything, use their service. Say you don't mind if disclosing their user patterns or something. But usually you don't look at that. You just scroll down to the bottom and say, "Hey, I accept." But essentially, tracking a device is needs to be a collaboration work between the firmware designer and the software designer. So typically, you put a unique identifier in the firmware, so it carries like an ID. So no matter when it registers into the IoT network, it pushes things to the gateway, and then gateway push the thing to cloud. And when you use the whole thing, you may register username with your address or telephone or email, and then that device gets registered under your name, right? If you're gonna return it, and they will do something in the backend. But you can't prevent those guys doing evil. Like for example, if they record all the logs, all activities, like controlling your home, it's not a surprise. But things get more sensitive if you open a smart lock to the cloud, because anyone can open your door. And it goes back to, I think, the first session of the account security. If somebody are compromised into IoT, AWS IoT, they pretty much can do a lot of things that you can never imagine. Yep. Oh, sorry. Let me get back to the slides.
Sorry, just getting ahead there.
That's the thing, right? Yep. Right.
Shane has an answer.
I
You
think
can just give us an answer. Also.
Device registration. Tries to build it as carbon certificates. So it's effectively over an SSL transport. The QTT provides reliable delivery and acknowledgement of pub subs. But that's the problem. First of all, how do you make sure, first of all, how do you get all the certificates on all the devices in a secure way? The second thing is, how do you anonymize all of that data so that you can't get personally identifiable behavior from a third party? And then you have the issue of, how do you know that the device that you're talking to is really a device? The SSL certificate gives you some level of assurance. So, I mean, there's a whole raft of issues in there, and they all, in my view, collapse once you start scaling. They become big issues.
Yeah, there's lots of issues.
Yeah, so I think essentially we don't have to dive into the design details, but essentially in the firmware level you got control of what to publish. Definitely you can use it as a user configuration. Say, for some events, I just don't want to publish. Just leave it in the LAN, don't push into cloud. And there's another paradigm, I don't want to confuse you guys. There's another paradigm introduced recently in the academic world, because I'm doing some research. It's called fog computing. It's not cloud. Cloud is too far. We do it in the fog. You set up a server at your home. It's just good enough. It's not perfect, but with super low latency and with very, very good security. You lock it in your laundry. You can do that in that way. So fog versus cloud can be an interesting debate in the years to come.
In between. One more question.
No, I can't address all the answers, but cognito are
So cognito tools are available in IoT?
yeah, which is not.
Okay. It addresses some of those issues.
So it addresses.
Awesome.
We should do a design session.
We need wireless mics, guys. We can't reach you, unfortunately, with the cables.
Yeah, is there anyone interested in start a business? I'm kidding.
Excellent.
I work for Daryl.
Excellent. Thank you very much. Any more questions at this point? No? Everyone good? Excellent, guys. Thank you very much for this evening. Thank you, Binqi. That was awesome. So just same time, same place next month. Our blog is there. If you're interested in presenting or would like to bring up a topic, then come talk to us. What we're going to do now is we're going to do the cloud conformity. Guys are going to come back up. Hey, we got lots of tricks. We're going to get somebody from the audience up to the rock. And filter and check. Oh no, let me fix it. Alright, okay, is everybody still here? Just going to take the first one. Or and then go. So who's Brian Ford or Brian Ford at Macquarie? Brian Ford? Hey, there we go. Congratulations. You have to sign up for Well done. So again, thanks to Cloud Conformity. Check it out, go online, sign up for, you can sign up for a subscription, guys, can't you? Yeah, you can sign up for a subscription, check it out. We'd love you guys to come back next month. We might open a little talk, a discussion, 5-minute discussion to start, to say how do you use the tool, what you thought was good about it, you know, feedback. So we're always looking for feedback on all of the tools, that'd be awesome. Thanks everyone, talk to you soon. Take it easy. Cheers, guys.